Hey everybody! Alright, so this year marks the Voyager's 45th anniversary, or launch anniversary if you're a geek like me and you like making words up. So, this is an unprecedented milestone in the history of space exploration. These two craft, the twin Voyagers 1 and 2, they were originally hoped to survive 5 years. We're at 45. So well done, JPL. This is truly incredible. It's an incredible story of engineering and science and dedication to continuing the science and also keeping aging craft alive. Alright, so let's take a look at the Voyager's mission. Yeah, that's right, I'm gonna keep doing that. I apologize. Sorry, not sorry. If you're not familiar with the Voyagers, let me catch you up. Okay, so these two craft launched in 1977 in reverse order, because reasons. Orbital reasons, to be precise. Voyager 2 launched in August of 1977. Voyager 1 launched in September. That's not nonsensical. NASA numbers their missions in the order that they are planned, and then they launch them however they need to be launched. So Voyager 1 is numbered Voyager 1 because it was planned first. Voyager 2, the backup, was planned second, even though its mission for what they intended dictated that it launch first. With that said, Voyager 2, because it launched just that little bit ahead of Voyager 1, is the oldest functioning spacecraft in the entire solar system. And these two craft are the farthest, which is just amazing. I'll get to that in a little bit. Okay, so why did we make these Voyagers? The minimum, the goal, if we achieve this, then Voyagers are a success, was to get flybys of Jupiter and Saturn. To that point, the only craft that had visited Jupiter was Pioneer 10, and the only craft that had visited Saturn was Pioneer 11. There was also a goal, a pie in the sky, we hope we can pull this off, thing called the Grand Tour. It was an alignment of the four outer planets that only happens once every 175 years. Okay, so if Voyager 1's flyby of Saturn got it a really great look at Titan, then Voyager 2 was free to follow a different path. And Voyager 1 got us a great flyby of Titan. So that left Voyager 2 free to gravity assist using Saturn to get it all the way out to Uranus, and then use Uranus to get it all the way out to Neptune. Okay. The Grand Tour. That means Voyager 2 is the only craft in history that has visited all four of the outer planets. And it is the only craft that has visited Uranus. And it is the only craft that has visited Neptune. Time for us to fix that, right, NASA? We're sending more and more craft farther and farther to answer those burning questions that we've got about the ice giants. Alright, now, one of the cool things about the planetary alignment that allowed for this Grand Tour is because of these gravity assists, it was able to cut down its flight path. So if Voyager 2 had been sent on a direct flight path to Neptune, it would have taken about 30 years for it to get there. But because of this Grand Tour alignment, it was able to do it in 12. So some milestones, some notable, now this is just a very brief overview of what these Voyagers have done for science and the world at large. Starting with Voyager 1, at Jupiter, it discovered that Jupiter has aurorae. We didn't know that. Lightning on Jupiter. Lightning, the first time we've discovered lightning on any other body in the solar system. Upper atmosphere lightning at Jupiter. Rings. Jupiter has rings. Voyager 1 showed us that. Also, volcanism on Io. It is it is for a fact the most volcanically active body in our solar system. It's a moon of Jupiter, and it's got the most active volcanoes anywhere. Not the largest, that's Olympus Mons. Mars has that credit. Earth has the most approachable volcanoes, but Io has the most. And we didn't know, because it's a moon. It's very tiny, and it's way out there. It's 500 million miles away. But because we sent the Voyagers, we were able to get images. All right, so what happened when Voyager 1 passed Saturn? I'm so glad you asked. Shepherd moons. Shepherd moons are tiny moons that sit within the ring system and create the divides in the rings that make, if you look at the, I'm going to date myself really badly here, but that's okay because Voyager has a record on it, so it's fine. So if you look at the rings of Saturn, there are gaps. And if you look at them from a distance, it sort of looks like Saturn has a record around it. And those grooves, some of them, those gaps are created by shepherd moons. Moons that sit and collect the ring debris onto themselves or scatter the ring debris away from themselves. Saturn's ring system is far more dynamic than we knew. Thank you, Voyagers. All right, Titan's atmosphere. Voyager 1 gave us an incredible look. This was the final goal. If you could just get the minimum from Voyager 1, it was to make sure that we got the information on Titan's atmosphere. And if Voyager 1 successfully gave us this great flyby of Titan, then Voyager 2 was free to continue on about the solar system. All right, so Titan's atmosphere, 90% nitrogen. Ours is about 80% nitrogen. So we've got that in common. Very cold. It's approximately minus 292 degrees Fahrenheit, or if you're like the rest of the world and you're Celsius, it's minus 180 degrees Celsius. It's frosty. So one of the things that Voyager showed us is that there are possible liquids on the surface. Methane and other complex hydrocarbons on the surface of a moon. It's potentially the only other liquid on the surface of a world in our solar system. Titan. Tiny Earth. So another huge accomplishment of Voyager 1, the pale blue dot image. It was one image as part of Voyager 1's family portrait. Now, Carl Sagan, he encouraged NASA, JPL, to use the Voyager cameras one last time to image all 8 of the planets. 9 at the time, but all 8 of the primary inner planets at that time, all in one go. Voyager 1 was the only craft in position to do this. And one of the images, the image aimed at capturing Earth, captured 1 pixel. Voyager 1 was so far away by 1990 when it captured this image that Earth is just 1 pixel in this exposure. And Earth is there. It's seemingly embraced by a ray of sunshine. So in 1990, February of 1990, after taking this sequence of 60 exposures that created the family portrait, Voyager's cameras were turned off because it was so far away already that its cameras were basically useless. So January 1st, 1990 is the official beginning of Voyager's interstellar mission. VIM, if you like acronyms. All right, other notable dates for Voyager. Voyager 1, February 17th, 1998, Voyager 1 passed Pioneer 10 to become the farthest human-made object, the farthest craft out from the sun. So, Voyager 1, it's our ambassador. On August 25th, 2012, Voyager 1 left the bubble of stellar wind from our star and became the first human-made object in interstellar space. And Voyager 2 followed 6 years later. So that's just Voyager 1's mission highlights. Voyager 2, again, only craft to visit Uranus and Neptune. Uranus, it found a twisted and rotated magnetic field. Neptune, it found a dark spot that we're still trying to figure out. Rings, it's amazing. Go deeper. I highly encourage you to continue researching these incredible craft. And while you're doing that, you'll probably run across the name Carl Sagan a lot. his name is inextricably linked for me with the Voyagers, and there's a reason. He was definitely a spearhead, a great proponent for all of the aspects of this mission, up to and including the Golden Record. Again, a mission to the stars, a message to the stars. It's called the Golden Record for a reason. It is quite literally made of gold. And that is because gold does not corrode. So this record, and if you're young enough that you don't know what a record is, well, good for you. But it's this old-timey disc that carries audio. But this record is special. This record also carries images. Analog encoding of visual images, along with 90 minutes of music from various cultures around the world, greetings from various cultures around the world in 55 languages, and nature sounds. And both of the records, they are hand engraved with this inscription: to the makers of music, all worlds, all times. The cover is in fact covered with instructions on how to play these records. And that's because these missions, these Voyagers, are meant to continue. Even when their power source is depleted, they will continue on to the stars, quite literally. In about 40,000 years, Voyager 1 will pass within a couple light years of Proxima Centauri. About 290,000 years, Voyager 2 is going to pass Sirius, the brightest star in our sky. So these Voyagers are our ambassadors to the stars. But how long can we keep them going? They're at 45 years when their original mission was 5. How much more life do these Voyagers have in them? Well, they are powered by plutonium. That's right. Within their RTGs, or radioisotope thermoelectric generators, say that 5 times fast, I dare you, are chunks of plutonium, and plutonium-238 specifically, which has a half-life of 88 years. And that means they are well beyond halfway depleted. So, what's happening is these RTGs are losing approximately 4 watts of power per year. And NASA and JPL, they have been turning off non-essential equipment, non-essential parts of the craft, non-essential power drains for years now. Things like heaters. And it turns out the instruments, the still functioning instruments that have had their heaters off for years, are still going fine. As of the time of recording, Voyager 1 still has 4 functioning instruments, and Voyager 2 has 5. And there was a rumor that they were going to be powered down this year because of the power loss. But there was a meeting a couple months ago. NASA has decided to continue funding the science teams that are receiving data from these 5 instruments through 2025. And then in 2025, because those RTGs are continuing to lose 4 watts of power every year, so the plan is to start powering down some of the instruments, even the functional ones that are still collecting information about the interstellar medium. There's another limiting factor to maintaining communications with these craft. That is their high gain antenna. The high gain it works at about 23 watts. So about the power consumption of a refrigerator light bulb. Now keep in mind, Voyager 1 is 14 billion miles from Earth, and Voyager 2 is 12 billion miles from Earth. So that we are able to communicate with them at all is the radio communication equivalent of taking a refrigerator light bulb, flinging it out into space, and then with a visible light telescope, aiming your telescope at that light bulb, and being able to see the pulses from that bulb 12 billion miles away and getting farther every day. This is a huge feat. And the only radio communication system on the planet that is capable of communicating with the Voyagers is NASA's Deep Space Network. And in order to maintain that communication, the main dish at each of the Deep Space Network, or DSN's 3 sites around the world, has been increased to 70 meters in width. So it's possible that by the early 2030s, we will lose the ability to communicate with the Voyagers. They carry our message of hope to the stars, like a message in a bottle. They are our steadfast Voyagers, and we wish them well.